The topic of this video is finding a quadratic function given its vertex and one other point. Let's solve this problem. Determine the quadratic function f whose graph is given. The vertex is -3, -4, and the other given point is 0, -13. Okay, let's go through the 4 steps together. The first step is to identify h, k, x, and y, and put them in the vertex form of a parabola, which I will write here. Y equals a parenthesis x minus h close parenthesis squared plus k. So I'm going to rewrite this, where I'm going to remove the x, the y, the h, and the k so that we can plug in the numbers at those locations. Y is -13, x is 0, h is -3, k is -4. Notice the parentheses here and here so that we don't have two symbols side by side. Okay, now we'll begin to simplify by following order of operations. Order of operations says that I should work inside grouping symbols first. So I need to figure out what is 0 minus -3. Well, subtracting a negative is adding, so this turns into 0 plus 3. Adding a negative is subtraction, so I can rewrite that as -4. Now, doing the addition, 0 plus 3 is 3. After grouping symbols comes exponents. 3 squared is 9. After exponents comes multiplication and division from left to right, so that would be this, the 9 times the a, which makes 9a. Now I'm ready to solve for a. Add 4 to both sides. On the right-hand side, the -4 and the +4 cancel, leaving just 9a. On the left side, -13 plus 4 is -9. Now divide both sides by 9. And we get -1 equals a. Or if you prefer, a equals -1. So now we know the values of a, h, and k. A equals -1. H is given in the problem as -3. K is given in the problem as -4. This allows us to now move on to step 3. Put a, h, and k in our vertex form of a parabola to get the equation of the parabola. Okay, so this time I'm only going to erase the a, h, and k. Leave the x and y. We need them in our equation. Equations of parabolas have x's and y's in them, so leave those there. A is -1, which, by the way, indicates a downward opening parabola. When a is negative, that means your parabola opens down, and since our graph opens down, that gives us confidence that we're doing this correctly. H is -3, which I'll put in parentheses. K is -4, which I'll put in parentheses. And now we will simplify. Okay, instead of -1 times, I can just write a hyphen. Instead of subtracting a negative, I can write adding. And instead of adding a negative, I can write subtract. So this is the equation of my parabola in the vertex form. However, this problem requires us to write our answer in the standard form. So we need to rearrange this equation so that it no longer has these parentheses in it, and it's of the form ax squared plus bx plus c. All right, so let's go ahead and do that. So we get y equals, we've got a hyphen. The exponent of 2 tells me how many times to multiply that x plus 3 times itself. So I have that. I'm going to distribute the minus to this binomial first. That's going to give me -x subtract 3 in parentheses times this x plus 3 subtract 4. Now I will use FOIL on the two binomials. So I get -x squared minus 3x minus 3x minus 9 minus 4. And combining like terms, I get my final answer, y equals negative x squared minus 6x minus 13. This is the standard form of a parabola. Now you might have noticed the negative 13 here and here. Is it just a coincidence that that number showed up in both places? Well, sort of. The y-coordinate of the other point does not always tell you the number that's here. However, if x is 0, then whatever number you see here will also show up in this location. This is a helpful tip to make sure that you do not make any mistakes. All right, that's the end of this problem.